to talk to you about how to keep your research integral and how to be compliant with the regulations. So we know that science depends on the ability to continuously build upon the research that came before, and we have to be able to trust the integrity of that research in order to advance. If there were some problems with the research that came before, then that can send a field off on a wild goose chase as people try to replicate or extend faulty research, or it can halt the progress in that field. So the National Academies of Science, Engineering, and Medicine identified these core values of research in 2017. So obviously honesty is at the crux of the enterprise, because that's about sharing your results without any deception and sharing those fully. Objectivity, of course, is the scientific hallmark of avoiding any bias or preconceptions, and openness is conveying your results fully, transparently, and it's also about being open to negative results or differing opinions. Accountability, being able to justify and stand up for your work. Fairness in how you treat other people in mentoring, collaborating, reviewing research. And stewardship is about that broader relationship within the research enterprise, within the institutions, and then around with society itself. And the integrity of research really depends upon individual and collective adherence to these values in planning, proposing, performing, reviewing, and reporting your research. So these values are perpetuated through skillful mentoring from one generation of researchers to the next. So as perhaps some new researchers in the field, you're being mentored by senior colleagues within your department, and you in turn are mentoring graduate students who are working with you. And that way you pass along informal and often unwritten standards, and hopefully engage in ethical discussions and talk about best research practices. Of course, the future of research is increasingly collaborative, as Dr. Doolittle alluded to earlier. Funders are increasingly encouraging people to develop these interdisciplinary, cross-disciplinary, transdisciplinary projects, because at the intersections is where some really interesting and important work occurs. We know that the complexity of modern problems is growing while the specialization is narrowing, right? So you need increasingly large teams. This graph is kind of hard to read, but you can get the general gist of it. It shows how science and engineering teams have consistently grown in size over the past 60 years. You can see the years at the bottom. These are sizes of author teams. So today, 90% of all science and engineering publications are authored by 2 or more individuals. And most articles are written by 6 to 10 individuals from more than one institution. So you can see that orange line is the one that's climbing highest. That's 6 to 10 individuals. The flat lines are 1, 2, and 3 authors. And then these with the really steep climbs are very large teams. So this can enhance productivity by distributing work across individuals, but it also magnifies the burden of communication and coordination. And these teams that we're gathering are increasingly large and increasingly diverse, because addressing these complex scientific problems requires contributions from a variety of disciplines, as we already articulated, but you also may need to include community members, industry members to help translate the research into the public sphere. And then you're also going to have people with diverse ages, backgrounds, cultures, genders, religions, ethnicity, etc. So this diversity can enrich a team, but it also means that the team members lack a common vocabulary, and that can pose challenges for effective communication. So there are a number of really valuable resources out there as you prepare to develop research teams. These are some publications that are free. You can download them online. The one title is Thriving in an Era of Team Science, and then also a field guide to collaboration in team science. And then there's this interactive toolkit where you can find a number of resources, publications on effective team science approaches, training resources to build team science competencies, and then strategies and discussion guides to enhance team communication. For example, the NIH developed this list of questions for collaborators, things that you want to discuss up front at the beginning of working with a team. So you have this early ongoing communication, which will enhance the success of the collaboration. You can see authorship is one of the issues that you want to address at the beginning. This can be particularly tricky because institutions, funding agencies, other researchers are going to judge you based on your publications. And so everybody wants to be listed as author, but not everybody necessarily deserves, has made the appropriate contributions, or really wants that responsibility, because if some problems arise within the publication down the road, then everybody who's listed as an author is responsible for that publication. So there aren't clear guidelines as to who should be listed by author. It really varies by discipline, institution, team, but it's important that you establish those expectations early. So this is a graph that was developed by the NIH, and it shows guidelines for authorship contributions. The colors represent, the green means yes, that person should be listed as an author, the red means no, and you can see that there's a lot of gray here, so it really depends. There are a lot of situations where it's unclear. So the only fully covered bars under administrative and technical support, that one's all red, and that one's if you have contributed resources. So clearly you're not an author just for having contributed resources. And this one down here is all green, and that's for original experimental work. So if you've done original work, then obviously you can be an author. And these also are very clear in terms of writing. So the drafting of the manuscript is fully green, reading or commenting on the manuscript is fully red, and having no contribution to writing is fully red as well. So that's ghost authorships, gift authorships, etc. So as I mentioned, there's not clear guidelines, but there are some disciplinary governing standards. So the uniform requirements for manuscripts submitted to biomedical journals that were identified by the International Committee on Medical Journal Editors are identified here. So these are adopted by about 500 medical journals, but again, it's going to vary in other disciplines. But the expectation is that an author should be able to meet all three of these conditions listed in order to warrant authorship for a particular article. So this is something that you and your team would want to be clear about from the beginning. Now, with collaborations comes potential for conflicts of interest. These can be perceived or real risks of private interests in the personal, professional, or financial areas that can compromise the exercise of professional judgment or obligations, and these can affect the design, conduct, or reporting of that research. Why this Lucky Strikes ad? What does that have to do with conflicts of interest? It can be pretty deceptive. It says that 20,679 physicians say Luckies are less irritating. It's toasted. Your throat protection against irritation, against cough. Right, so as you may know, in the early 1990s, 1993 I think it was, the EPA determined that secondhand smoke could be classified as a Class A carcinogen. And of course the tobacco industry was panicking at the prospect of smoking being prohibited in public spaces. That would affect their sales and profits. And so they launched a systematic campaign. They funded hundreds of academic research to disprove the EPA's finding. They set up commissions to go and present at professional societies, again, trying to sway the research community. They had in-house scientists on journal editorial boards, so they really tried to control the narrative. Now, this is not to say that all industry-sponsored research is tainted, but there is this possibility of conflict of interest, which is why we have some laws regulating that. Industry tends to support research that's going to show their product in a favorable light. Consequently, scientists tend to develop sympathies with sponsoring industries. So the story that they tell in their research may be slanted towards the benefit of that product, and the conclusions that they present may downplay the harm or risk of that product. And it's not that they're their science is wrong, but they tend to self-censor their work to appeal to the funders, and so they might sidestep critical questions. As you might remember in that Lucky Strikes ad, it was all about how it was less irritating, right? It's not going to make you cough. Is that really the question that we want these physicians to be investigating when they're studying the effects of smoking? The questions themselves can become very selective, which then influences the choice of topic, the design of the experiment, collection of data, analysis, and presentation. So it's this predisposition of the funding effect calls for strong conflicts of interest policies to minimize bias. And of course, we first have to recognize the risk of bias, be aware that we may be biased because of these different interests, and then try to manage or mitigate that bias. And it can be managed through disclosing the conflicts, through third-party monitoring if necessary, or even changing somebody's personnel or their role on the project. And the regulation is that if you have a significant financial interest, that's what SFI stands for, that's greater than 5,000, you're required to disclose that. And as you came aboard here at SDSU, I'm sure that there were some conflict of interest disclosure form that you had to complete. That's an annual process. You're going to be updating that as needed. And then when you're proposing to an agency, you're also going to have to identify potential conflicts of interest. And if you're applying for funding by Public Health Service Agency, Centers for Disease Control, Food and Drug Administration, National Institutes of Health, Indian Health Services, et cetera. So those agencies are all funded by PHS, and so if you're applying to those agencies, they have a separate conflict of interest form for you. Now I'm going to tell you about some of the regulatory committees here at SDSU. We have the Institutional Animal Care and Use Committee, known as IACUC. The chair of that committee is Jeff Clapper, and he is not here with us today, but Michelle Mushanti is, and she's going to come up here in just a minute to talk to you about animal research. Another regulatory committee is the Human Subjects Committee, also known as the IRB, or Institutional Review Board. And Dr. Matt Vukovic is the chair of that committee. And we have the Institutional Biosafety Committee, IBC, and our chair is Dr. Daniel Scholl. So I'm going to talk a little bit about human subjects and biosafety concerns, but first we're going to hear from our university veterinarian, Michelle Mushanti, about animal subjects.
So any project that you do that involves vertebrate animal, you have to fill out an animal use form. Especially when you're working in animal science, one of the biggest concerns is people hear the term exempt, and they think that that means that you might have a project that means you don't need to fill out a form. What the term exempt means is you fill out the form, and it might be exempt from full committee review if all you're doing is a feed and weigh. If all you're doing is, feeding the animals and then weighing them, that might be something that might be exempt from full committee review, but it's not exempt from animal use form. So you always need to fill out the animal use form. So what the term exempt means in our case is it means exempt from full committee review, which means you turn in the form and then the IACUC chair and I take a look at it and decide whether it needs to go to the full committee. So, just make sure that you always fill out the form. All the information on our IACUC is on Inside State. It's not on our regular, our public side. So what you have to do is go to research on this Inside State. When you click on research, it will, over on the left, it'll say IACUC. And when you click on that, that will give you all the contact information and everything you need. It gives up with IACUC policies. Also, if you want to collaborate, Dianne was talking about collaborating. We've had more and more animal science people collaborating with veterinary biomedical science department. So if you want to see how one of your feeds might help get an animal through an E. coli outbreak or something like that, any infectious research that you need to do that where you're going to actually involve challenging them with an infectious agents, we do it in the Animal Resource Wing. That's a building, it's just to the northeast of the Animal Science Building. We're surrounded by construction right now. If you click on the Animal Resource Wing on this, ARW, that will bring up everything about the Animal Resource Wing that you might want to know. any questions you have on scheduling, anything like that. I can give you the manager's name. That type of information is on here too. I'm the one that you should contact when you're ready to start a project, just to help if you need any help on coming up with any pre-project issues that you might be concerned about. If you discuss things with me before you take it to the IACUC committee, I can usually, when you come before the IACUC committee, I'm the one that usually has the most questions. So if we can get stuff taken care of before you even bring it to the committee, we can usually get things smoothed out.
The Belmont report identified specific principles: respect for persons, beneficence, and justice. And these are the principles that govern our research on human subjects. So the idea of respect is closely tied with the idea of autonomy, so that subjects should have decisional capacity. They should give voluntary informed consent. They should know everything about the research that they're engaged in. And if they are particularly vulnerable groups, such as children, prisoners, and other categories of vulnerability, then there are special protections that should be in place for them. Beneficence is about minimizing risk so that the benefits outweigh the harm. And then justice is about, that really influences your inclusion and exclusion criteria. You want to make sure that the people that are participating in the research aren't just a convenient group. Maybe they're accessible, they're vulnerable. You can engage them in research even if they're not necessarily relevant to the issues that you're studying. So it's to make sure that the benefits of research the benefits and costs of research are applied equally across various groups. So these rules, the principles of the Belmont report, were codified in the Common Rule, and this is a CFR 45 that all of these federal agencies adopted, and it's really rare for a variety of agencies to adopt a single regulation, but they did. It was adopted by 18 federal departments and agencies. And these govern the establishment of institutional review boards, determining what the IRBs do, what informed consent looks like, how the study should be conducted. And institutions that pursue human subjects research need to follow those rules. And now there are some new rules that are coming out. The Common Rule has been in place since 1991, and they're just now being updated to reflect some of the changes in technology to make minimal risk research easier to conduct and to reduce some of the administrative burden. So the federal definition of human subjects is changing a little bit with the new rules. They specify that it is a living individual about whom an investigator conducting research obtains information or biospecimens. So it used to just be data. Now they've expanded that to information or biospecimens through intervention or interaction with the individual. And then it's not just the collection of that data, but using, studying, or analyzing the information or biospecimens. Or somebody who obtains, uses, studies, analyzes, or generates identifiable private information or identifiable biospecimens. So if you are receiving some coded so that you can't identify who the subjects are, and that was collected for something other than your research project, that's not considered human subjects research, right? But it has to, if it's identifiable information and you're interacting with the person, then it's human subjects research. Research they identify as a systematic investigation that involves research development, testing, and evaluation that's designed to develop or contribute to generalizable knowledge, and that's a key point here. So it's the systematic investigation and the intent to contribute to generalizable knowledge. So some people say, well, I want to publish this, so it's research. That's not necessarily the defining characteristic. So what's really important is the intent of the project. So if your intent is to contribute to generalizable knowledge, if you're studying a hypothesis or research question, if your analysis is looking for trends that can be generalized, if you're generating knowledge that can be applied to a larger source that builds on knowledge or enables further research, then it can fit the definition of research. The new rules also identify specific areas that are not within the rules jurisdiction, so scholarly activities that focus on a specific individual. So maybe you're doing oral history or journalism, writing a biography, historical research. So if it's just focused on one individual, that's not going to fit the federal definition of research. If you're doing program evaluation and the results are just internal to a program, then that's not considered research. Public health surveillance activities. So these are all areas that would not meet the federal definition. And then they would not be subject to IRB review. So when you think you're engaging in human subjects research and you're not sure if it would fit that federal definition, we have a decision chart on our website where you can walk through some targeted questions to determine whether or not it really is human subjects research and if you need to submit a proposal. The IRB will then determine whether or not it's exempt from review. So these are some of the categories of exemption. So if it's normal educational practices, which includes some surveys or interviews, working with existing data, testing food. These are some new things, benign behavioral interventions and secondary research use. It may not be exempt from review, but maybe there be an expedited review, so it's only one or two committee members that need to review if there's no more than minimal risk, and you can see some of the categories there. If it doesn't fit those categories, then it needs to go to full committee review if there's greater than minimal risk that cannot be avoided. So you would submit an application to the IRB. There's a link to the application form there. A representative from the IRB, likely me, will communicate with you, make sure that everything's in place, and let you know if there are any modifications that need to happen, and then give you a letter of approval. With your application, you're going to submit certification of city training. So SDSU has a subscription through City, and we have a single sign-on. So when you log into City, you want to click on Log In Through My Institution, and that way you can use your SDSU credentials to log in. And if you're conducting human subjects research, you're going to need to take one of two courses, either social behavioral research or biomedical, depending on the type of research that you're doing. If you're doing animal studies, you're also going to need to do City training for the species specific, as well as working with the IACUC. And then we're also adding some biosafety courses as well. If you're engaged in research in these areas, so recombinant DNA, genetically modified organisms, if you need federal permits from APHIS, CDC, EPA, etc., any of this type of research is going to require registration with the Institutional Biosafety Committee. There's a link to the registration form there. This is to make sure that your research conforms to the NIH guidelines and that it minimizes any risks to the environment, to the personnel, or to the institution. Export controls is another area of regulation. So these are laws that control the conditions under which certain technologies, informations, and commodities can be shared, can be transmitted overseas, or shared with a foreign national on U.S. soil. So the majority of SDSU research fits under the fundamental research exemption. So if your research is ordinarily published and broadly shared in the scientific community, it's exempt from export controls regulations. However, if your results are not going to be published, maybe you're working on some industrial research and they won't allow you to publish it in the scientific community, it may be subject to controls. Or if you're working with equipment, an area of research with direct military application, or maybe a dual use, perhaps your research has some civilian and military applications or can be weaponized. Often research in these areas are potentially subject to export controls. Then you'll want to contact the System Export Control Officer. These are also some triggers that you might consider if you're shipping equipment to a foreign country, collaborating with foreign colleagues in foreign countries. You can read through this list. If you're engaged in any of those things, you'll want to talk to our System Export Control Officer, Katie Ludvigson. She's out at the School of Mines, but she serves the entire Border Regions system, and so you can connect with her through that contact information there. There are also some regulations around unmanned aerial systems or drones. This area is regulated both by BOR and SDSU policy. It's highly restricted for outdoor use. There are some opportunities for indoor use on campus or outdoor use at the research park. And of course, there's a form that you can complete. There's a link there. That's routed to your department head, dean, and then submitted to the vice president for research for final approval. And if you are submitting that, you need to include your proof of operator and observer training along with the form. Research misconduct. So the federal definition of research misconduct is fabrication, falsification, and plagiarism. So it's very specific. It's about making up data, manipulating materials, data or results, and then, of course, using somebody else's words, ideas, or processes without credit. And I point out that this is in proposing. So it's if you're writing a grant proposal, if you're performing your research, if you're reviewing somebody else's research, or you're reporting your own results. Under all those areas, these rules apply. Research misconduct has myriad negative consequences to the individual. It can send somebody's research off on the wrong area, waste their effort, people who are trying to reproduce and extend that research. It can sidetrack education and careers for people who are involved in the project. The reputation of the institution, the journal that publishes it, the collaborators, they're all harmed. There are financial consequences. If it's a sponsored project, of course, the sponsor's funds are being wasted. There's an institutional investigation that needs to be conducted, which is very expensive, and then any civil litigation that may result would also be a heavy burden. And then, of course, the social impact. If it's in health research, it can compromise the public health, the advance of knowledge is curtailed, and of course, public confidence in science is diminished. Now, not all research misconduct is on the grand scale. There are also many detrimental research practices. They are really much more widespread and can ultimately be more damaging to the research enterprise than full-scale research misconduct. Examples might be dropping variables or cases, or running multiple studies until you get the results that are significant and only reporting those ones. Different ways of crafting your study so that it looks stronger than it may have been, and these are all going to sway the research record and ultimately be damaging. So there are a number of drivers that can lead somebody down this path. So the funding patterns in the U.S. contribute to these research environments that have these characteristics that social behavior research suggests contribute to an environment conducive to cheating. High stakes, competition, low expectation of success, these are often the environment in which research is conducted, and it's also demonstrated to be an environment conducive to cheating. In addition to the environmental drivers, there are also personal drivers. So if you feel like your goals are being blocked, if there's some injustice, and then we have these psychological tendencies that can affect us as well. So this ethical fading is the idea of when you're focused on an objective and there's pressure applied, the moral implications of your decisions may fade from view. There's also moral disengagement, where you kind of reconstruct reality so that what you're doing seems more honorable than it is, just to mitigate any guilt that you may feel. This fraud triangle shows that there are 3 points. There's motive. It might be the pressure of publishing in the research environment, and then opportunity. They're your data, and so it's easy for you to manipulate them if necessary. And it's really easy to rationalize that, right? You may have a strong belief in your theory, and you think that the data just need to be massaged a little bit so that they show the theory that you believe is true. So we need to be aware of these tendencies and combat them. There are other factors that can influence our ethical decision-making, how your social groups or your colleagues, friends, or family, how they feel about the action, how close you feel to the people that are going to be affected by the decision, what kind of harm may occur, and if you're likely to be caught. This is a very basic ethical decision-making model. It begins with feeling that something's not right, and then weighing different choices, trying to determine better or worse, navigating competing tensions, and then deciding what you're going to do and acting upon it. Now, many people go through those first 3 stages of awareness, judgment, and intention without actually taking the action that's ethical. And one of the primary reasons for that is the power of other people present and what they think about the person making that decision. That's the most often cited factor for not making an ethical decision. The most important and effective means for preventing misconduct is the research community itself. We're self-regulating, and we need to be aware of our own tendencies and those of our team, and interrupt some of those rationalizations that may lead us down the wrong path. And so we need to help one another conduct ethical research, because science is a communal effort, and we need to help each other.